Okay, so here we have this interesting integration problem here. So let's see how we're going to go about it. So we have the question written here, integral of dx over x, open bracket, ln of x, close bracket, all raised power m. So looking at the question, we cannot integrate directly. It is not in standard form. So we are going to check and know the right approach. But before we know the right approach, we have to rearrange it and make it look more simplified than this. So let's go there. So we now have the integral of 1 over x, open bracket, ln of x, close bracket, raised to power m, and then we have our dx. Okay, this is okay because your dx times 1 still gives you your dx. We just have the term here separately written. Again, we can still rewrite this and let it be clearly in product. Let the x and the ln of x be clearly in product with each other. Although they are in product with each other, but let it now be very clear. So we now have the integral of, we can now have this as 1 over x times, we now have 1 over ln of x all raised to power m. So of course 1 times 1 still gives you 1, and then the x times ln of x raised to power m still gives you the term here. So we're in the right track, and then you fix your dx, and then we can rewrite this and change it into a negative index. So we now have x raised to power minus 1 into bracket. This one also, I'm going to rewrite this into a negative index, ln of x raised to power minus m, and then dx. Okay, so now it is now clearly, they are now clearly in product with each other. And most times when you want to deal with integrals where you cannot integrate directly, you have to rewrite them and make sure they are clearly in product with each other, and then you now know the right approach to take. So here, if you look at what is in the bracket, ln of x, the derivative of ln of x can eliminate the value here, can eliminate the x here. So we're going to apply a U-substitution since we have established the fact that the derivative of ln of x can eliminate the other variable here. So let's go there. So I'm going to make my u to be what is in the bracket. So rewriting this, we're going to use a U-substitution, which is, most times we call it change of variable. So u is now going to be equal to ln of x. So rewriting that, my u will now be equal to ln of x. And of course, I'm going to now differentiate. I'm going to, with respect to x, so it's going to be du dx. So du dx will now be equal to, the derivative of ln of x is 1 over x. And since we are going to replace our dx here with a new value, which is going to be du, is going to be involving the u. Since we are using a u substitution, that's why it's actually called change of variable. So I'm going to treat this du dx as a fraction. I will cross multiply and I'll make dx the subject of the formula here. Any value I get for dx, I'll replace over here. So let me cross multiply. So dx times 1 still gives me dx equals, then du times x gives me x du. So finally, the value of dx is now x du. So anywhere there is dx in this integral problem, anywhere there is dx, I'm fixing x du dx. So I'm going to rewrite this. So the integral, I can still leave this one as 1 over x, it doesn't change anything, times this ln of x is now u. Remember, we made it to be u, so I'm going to write u times u raised to power minus m, and then this dx, don't forget, dx is now x du. So I'm replacing this dx with what? With x du. So x du, and then of course this one means 1 over x times u raised to power minus or m, then times this x, then times the u. So I can now finally have x cancelling x. That is the main reason for the u substitution, so that I'll just have my u and the u left, and that means it will now be in standard form. So rewriting it, and I have the integral of u raised to power minus m and then the u. So this is now in standard form. We can now confidently and conveniently integrate the problem with respect to u. Don't forget that. So following the direct method, rewriting this, and I have the integral. So this one now becomes u minus m plus 1 over the minus m plus 1 also comes down, minus m plus 1. And I can still rearrange this to now be u raised to power, write the 1 first, and write the minus m second, over, again, for the 1, for the denominator, write the 1 first, and write the minus m second, then plus c. But we still have to bring back the value of u. Remember, we made u to be what? Ln of x. So anywhere there is u in this answer, I'll just fix ln of x there. So rewriting this, my u is what? Ln of x, then raised to power 1 minus m, over the 1 minus m, and then plus c. So this is your final answer.